Intro, source, tutor, voiceover, presenter. AI agents cannot spend money autonomously because every payment rail on the planet was built to authenticate a human, and an agent is not a human. That one sentence explains why the most capable AI systems in history, systems that write code, negotiate contracts, manage entire supply chains, all stop at the same step, the checkout page. Today, we are going to trace exactly why this happens, not at the surface level, at the architectural level. We will look at where the authentication model breaks, where the identity model breaks, where the settlement model breaks, and what infrastructure actually solves this. By the end of this video, you will understand the specific failure modes. You will know which proposed solutions are incomplete, and you will see what a full-stack agent payment architecture looks like. This is not a vision piece. Every claim in this video is backed by a specific artifact, a real protocol, or a concrete number. Let's start with the biggest picture possible. Section 1. The architectural claim. 2 o'clock, 7 o'clock. Every payment authentication system built in the last 80 years shares one foundational assumption. The account holder has a body. A signature requires a hand. A PIN requires memory that belongs to a person. CVV requires physical possession of a card. 3D, secure requires a phone number tied to a human identity. Biometric authentication requires a face or a fingerprint. An AI agent has none of these things. This is not a solvable problem within the existing rails. You cannot teach an ACH transfer to accept a non-human principle. You cannot teach a Visa gateway to issue a card to a software process. These systems were not designed with that use case in mind, because in 1972, the use case did not exist. The principal assumption is load-bearing. It runs through every layer of the stack. Card networks require a named card holder. Correspondent banks require a legal entity with a registered address. Payment processors require KYC documentation that maps to a human or a human-controlled business. Fraud detection systems flag non-human transaction patterns as anomalous. None of these are bugs. They are the system working as designed. The system was designed for humans. So when you deploy an autonomous agent in 2026 and it hits a payment gate, it is not hitting a fixable UX problem. It is hitting the foundational principal assumption of the entire global financial system. That is the architectural claim. Now let's go into the specific failure modes. Section 2, the 4 failure modes. 7 got towards $1,400. There are 4 distinct places where agent payments break. Most builders hit all 4 within the first week of trying to give their agent financial autonomy. Let's go through each one precisely. Failure mode 1. Identity. KYC. Know your customer. Exists to map a financial account to a verified human being. Every regulated payment processor requires KYC before funds can move. An AI agent cannot complete KYC. It has no legal name, no date of birth, no government-issued identification, no residential address. Some operators try to solve this by completing KYC themselves and then delegating credentials to the agent. This creates a liability gap. The operator is legally the account holder, but the agent is making the spending decisions. If the agent makes a payment, the operator didn't explicitly approve who is responsible. That ambiguity is not theoretical. It is the reason most enterprise legal teams prohibit giving agents direct spending authority on corporate accounts. Failure mode 2. Authentication. Even if an agent has access to a payment credential, a virtual card, a stored account number, authentication challenges stop it. 3D Secure version 2, deployed at most major e-commerce checkout pages, sends a one-time code to a registered phone number. The agent cannot receive or enter that code without human intervention. Cardholders have chargeback rights that exist specifically because humans make mistakes and get defrauded. These rights create obligations for card networks to include friction in high-risk transactions. That friction is designed to slow down automated processes, which means it is designed structurally to slow down agents. Failure mode 3. Settlement latency. Let's say an agent successfully gets past identity and authentication. It initiates a payment. The payment enters an ACH batch cycle. ACH settlement takes 2-3 business days. The agent's next task depends on confirming payment receipt. The counterparty requires confirmed funds before releasing access or inventory. The agent is now in a 48 to 72-hour hold state, burning compute, potentially timing out orchestration contexts. For a human running a business, 2-day settlement is inconvenient. For an agent running an automated pipeline with tight dependency chains, 2-day settlement is a structural blocker. The speed mismatch between agent execution time, milliseconds,